Bismillahirrahmanirrahim. Thought of the day is, it does not matter how slowly you go as long as you do not stop. Assalamu alaikum everyone. My name is Dr. MOMENA and I'm a PGR in Community Medicine Department. I'm going to present the topic of regression analysis under kind supervision of my professor, Dr. Saira. Moving on to the learning outlines, we will be discussing the definition of regression, the types with its examples, the assumptions, the correlation versus regression, limitations, the recent advances, and at the end, we will be discussing some MCQs. By the end of this session, the participants will be able to describe regression in terms of its types, applications, and limitations. Now, moving on to the definition, regression analysis in data sciences is a statistical method that is used to model and analyze relationships between variables. Its main goal is to understand how the typical value of a dependent variable that can be target or outcome changes when one or more independent variables like features or predictors are varied. Regression is used when we want to predict a number like sales, temperature, or prices based on other data. Now, moving on to the core concept of the regression, we have dependent variable, which is what you're trying to predict. For example, a house price. Then independent variables, the inputs that we use for predictions. For example, the number of rooms and location as per the house price. Coefficient, data that tells us how strongly each features affects the output. Then we have the intercept, which is the base value where all features are zero. Then we have an error or residual, which is the difference between predicted and actual values. Here is a graph which is presenting all the core concept. Along the x-axis, we plot the independent variable, and along the y-axis, we plot the dependent variable. Then there is the intercept. This is the regression line. This is the observed value, and this is the difference between the estimated and the observed value is the residual or error. We are going to discuss each and everything in detail in the next slides. Now, moving on to the types of regression, we have various types of regression, which are according to the different types of data which is present. Number one is linear regression. Number two is logistic. Three is Poisson. Fourth is quarks. Linear regression we use when we have continuous variables and when they have a linear association with each other, which means when we plot a graph, we get a straight line between these two variables. So when we have this kind of data, we use linear regression, which is the simplest form of regression. Example would be the calculation of blood pressure using BMI or cholesterol level using BMI. Then moving on to logistic regression. This type of regression is used when we have binary outcome data, when we have the answer as yes or no. Example is the presence of a disease or absence of a disease. We use this kind of regression. Then comes the Poisson regression. This is also very important when we have count outcome data. We use Poisson regression. The example would be the number of hospital visits. Then moving on to the quarks regression, it is used when the time to event outcome has mentioned. The example would be time until the death in cancer patients. Moving on to the other types of regression are multiple linear regression. So this type of regression is very similar to that of the linear regression. In fact, it is said as the extension of linear regression. But one important thing is it has a lot of, it has multiple features, means multiple variables. The independent variables are multiple. Otherwise, all the other situation is similar to the linear regression. So the example would be predicting salary based on education, experience, and age. Another one important is polynomial regression. So this type of regression is used when the data is non-linear and when the data isn't best fit by a straight line, but a curve or a wave or a parabola. So example would be a car speed versus braking distance. Like braking distance increases slowly at first, then increases faster as speed rises. So we get a variety of data, and this data will not be able to be forming a straight line on the plot, but instead a wave or a curve. So at that point, we will use a different type of a model, which is polynomial regression model. Then comes the ridge lasso, elastic net, etc. These are the special types of techniques of regression which are used to handle the overfitting by penalizing large coefficients or regularization. So when we have too many variables, and all those variables have different amounts of importance in the data collection and data representation and interpretation, we use this type of regression to decrease to basically handle those large coefficients and only putting emphasis on the coefficients that are important for the study. So moving on to the analysis process, we are going to discuss the process by which the regression analysis has been done on a simple data. First of all, we have to identify the dependent variables, the outcomes, and the independent variables, the predictors. And then we have to formulate a hypothesis about the relationship, whether it has a positive relationship or a negative relationship. We have to formulate them. Then we have to form a pair, which is choosing the variable x and y to analyze, use exploratory data analysis like scatter plots to check the potential relationships, plot all your data points with the independent variables x on the horizontal axis and y on the vertical axis. Then is the assumption checking. We'll be discussing the assumptions separately along with each type of regression. So here we ensure the assumptions like data is linear, data is independent, data is homogeneous, and normality, they are met for regression analysis. Then the process-based pre-processing comes where the missing values are handled, the standardized variables are then formed, and encoding is done for the categorical variables. Then the data is split into two sets of training and testing for model building and evaluation. Then a regression line is formed. So a model building is done then according to the type of the data. If it is continuous and linear with the single variable as an independent variable, we will use the linear regression, otherwise multiple linear, and other types of data, other types of models can be used. So for a simple linear regression, the regression line is represented by the equation y is equals to beta naught plus beta 1 x plus eta, where y is the dependent variable, x is the independent one, beta naught is intercept, beta 1 is slope, eta is the error term. And in multiple regression, we have this formula, y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta n into xn plus eta. Now, moving on to the further, the model will be evaluated by assessing the model fit using R-squared and p-values, and residuals for randomness are checked. Model validation is done. Use the testing set or cross-validation to ensure the model generalizes well to new data. And last interpretation of the results will be done, which is interpreting the coefficients to understand the effect of each predictor on outcome. A significant p-value suggests the predictor significantly influences the dependent variables. Models can be defined if necessary, adjusted the model by adding interaction terms or using regularization techniques like lasso and ridge, as we have discussed. Deploy model after validating, use the model to make predictions on new data. So in this process, we have come across various terminologies that are new to us. One is regression line. In a sense, regression analysis helps find the best fitting line or equation that predicts the dependent variable based on independent variables. So this line's equation shows the relationship between the predictors and the outcome, that is independent and dependent variable. So what is a regression line? It is a straight line that best represents the relationship between these two variables. In regression analysis, it is the line that minimizes the differences or errors between the observed data point and the predicted value. So how we get a regression line? We have to start with a scatter plot. We have to plot the x and y variables along the axes, and we have to observe the trend or pattern of the data. If it is increasing, both are increasing, then we see a positive relationship. If both are decreasing, we see a negative relationship. Then we have to fit a line through the point. The goal is to draw a line that is as close as possible to all points. This line is the regression line. So in simple linear regression, the regression line is represented by the equation we have already discussed. This is known as regression equation. Here, y is dependent variable, x is independent, beta naught is intercept, beta 1 is slope, and eta is the error term. Now, this is the regression line illustration. So the x-axis rainfall is around the x-axis, and umbrellas sold are around the y-axis. We have plotted a scattered plot, and then we have joined all the lines with the best fitting line, which is known as the regression line. Now, what are the key characteristics of regression line? The slope beta 1, it determines the direction and strength of the relationship between x and y. If it is positive, then both increases. If beta 1 is negative, then both variables decreases. The intercept, the intercept is the point where regression line crosses y-axis and the value is 0. Now, what is best fit? It is the line which is determined by minimizing the sum of squared differences between the observed values and the predicted values. This is known as the least squares method. We are going to discuss this method again. So in a scatter plot, the regression line is the straight line that best captures the trend in the data points, helping predict the values of dependent variables for the given values of independent variables. Now we have this concept of how the best line is chosen. So one method is the least square method. It is a mathematical way to find the best fitting regression line through a set of data points on a scatter plot. It minimizes the total of the squares of the vertical distances called errors or residuals. Now, how we form a best line? A line is drawn with some slope and intercept, and for each data point, measure the vertical distance between the actual point and the predicted point. This is called as error or residual. Then squares of these distances are taken, which makes the distances positive as well as emphasizes large errors. Then these are added up, the sum of the squared distances. This gives the sum of square errors, and then the line is drawn that makes this total as small as possible. This is the least square regression line. So here is this least square method graph representation, which shows the residual or eta, which is shown in the formula. Now, linear regression, this is used when you want to study, model, or predict the relationship between a dependent variable and an independent variable, assuming the relationship between them is linear, which is a straight line. So this is the equation which has been shared before in the previous slides. Now, what are the assumptions? These are the assumptions that have to be fulfilled before applying the regression. And if you are not fulfilling these assumptions, the data will have bias and we have false results. Before applying, so this checklist must be fulfilled. Number one is linearity, which is the relationship between x and y variables must be a straight line. Otherwise, we cannot apply linear regression. Number two is independence, that is observations must be independent, no repeated measures are taken. Then is homoscedasticity or homogeneity, which is the spread of the residuals. The residuals are the errors we have found on the graph. So the spread variance of the residuals, it should be constant across levels of x. Then normality is there, that is residuals or errors, they should follow a normal distribution. If these assumptions are violated, results might be biased. Moving on to multiple linear regression. So this is an extension of simple linear regression. Instead of one independent variable x, we have a lot like 2 or 3 independent variables to predict a dependent variable, which is y. The goal is to understand or predict the value of y based on several x variables. Here is the equation of multiple linear regression, which is y equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3, so on and so forth to beta n xn plus eta, where y is dependent variable, x1, x2, and so on, xn is equals to independent variables. Beta naught is intercept, beta 1, beta 2 to beta n are slopes, which is the effects of each predictor, and eta is the error term. Now, there are also certain assumptions for using the multiple linear regression. These are similar to that of linear regression, linearity in terms of linearity, independence, homoscedasticity, and normality. But one other important thing is no multiple linearity, which is independent variables should not be too highly correlated with each other. Otherwise, if this is the case, we get a bias. When to use? When you believe there are more than one factors that are affecting the outcome, when you want to control for confounding variables, when you want better prediction accuracy compared to using just one variable. Moving on to logistic regression basics, this type of regression is used when we have a binary outcome, for example, disease is present or absent. The model is represented by the logistic regression equation, which is log into p by 1 by minus p is equals to beta naught plus beta 1 into x, where p is the probability of the event happening and the log odds are modeled as a linear function of predictors. One more important difference of logistic regression from the other regression types is that we get an odds ratio as a result as compared to that of coefficients, which is the case with the other regressions. We will see here. The output is usually represented as odds ratio instead of coefficients. Example is OR is equals, for example, if we get an odds ratio of 2.5 in case of a smoker is having a lung cancer or not, this would be implemented as the smoker having a 2.5 times higher odds of getting a lung cancer as compared to non-smokers. So this is just an interpretation of the result, which comes out after logistic regression. The tip is odds ratio. If it is more than 1, it shows a positive association with the particular variable. If it is less than 1, it shows a predictive effect for that variable. And if it is equals to 1, there will be no association. So this is another example of interpretation of results for linear regression and logistic regression. So we have done for the logistic regression, now we'll see linear regression. If the coefficient comes out to be 2.5, we interpret as each 1 unit increase in predictor results and a 2.5 unit increase in the outcome. So this is a way of interpreting the result. Okay, now moving on to meta regression. This term is also very important and it requires a separate lecture. but I will shortly describe it here. It is meta-regression analysis. It is an advanced statistical method that is used in meta-analysis to explore and explain heterogeneity, that is differences in study results. In simple terms, when we combine results from multiple studies, like which is known as meta-analysis, you often find that studies don't all give exactly the same effect size. So meta-regression, it tries to find the reasons for these differences by looking at study level characteristics, which are called as moderators or covariates. Now, moving on to the common examples or applications of different types of regression, we have logistic regression in analyzing factors associated with vaccine hesitancy, Cox regression in estimating the survival time after tuberculosis diagnosis, Poisson regression in modeling the number of malaria cases in different districts, and linear regression in predicting systolic blood pressure based on BMI. For example, if we add salt intake history, family history, other comorbid conditions as other variables along with BMI in predicting blood pressure, then we will get a multiple linear regression. Now, there are certain cautions or important warnings that must be fulfilled or must be known while using regression. One is correlation is not always an equal to causation. That is, just because two variables move together doesn't mean one causes the other one. Then comes confounding, which is we have to always adjust for confounders, those variables or coefficients that are affecting both the outcome and effect to get the true effect. And then is the effect modification. That is, we have to know that sometimes the relationship between exposure and outcome, it changes across levels of other variables, which is known as interaction. Then is model misspecification. For example, if we use wrong predictors or wrong assumptions, then we'll get misleading results and bias. Moving on to another important thing, that is correlation versus regression. Oftentimes these are confused, but there are certain differences between these two. In terms of correlation, coefficient is a measure of degree of covariability or association between X and Y. And in terms of regression, the objective of regression analysis is to study the nature of the relationship between variables so that we may be able to predict the values of one on the basis of another. So correlation is the measure of covariability or association, while regression is going to measure the prediction of the prediction of one variable on the basis of another one. Other differences are correlation is merely a tool of ascertaining the degree of relationship between two variables, and therefore we cannot say that one variable is the cause and the other is the effect. However, in case of regression, it's also not always the case, but sometimes the regression analysis will be taken as an independent while the other is independent, thus making it possible to study the cause and effect relationship in some circumstances. Then correlation coefficient is independent of change of scale and origin, while regression is independent of change of origin but not of scale. Then moving on to the last point, this is that if both of the two variables, they are symmetric and can be used in terms of each other. However, in regression, we have to be very careful about these variables because one is dependent and the other one is independent. So this is a summary of the differences between these two. The correlation has a descriptive purpose, as well as the linear regression has prediction and for the designed experiments. Now we measure the R value in correlation, and in linear regression we have R, R squared and R squared adjusted. Then we have paired variables in correlation, and we have paired variables in linear regression. 2, 3 or more can also be possible in case of multiple regression. Then we have no differentiation between the variables as we have studied, but we have one independent and one independent variable in case of regression. So fits a line through the data implicitly and explicitly in linear regression. Correlation does not show cause and effect. However, linear regression attempts to show cause and effect. This is the graphical representation. The difference lies in the graphs as well. The conclusion is we have to appropriately select the model on the basis of outcome, time, and the data. Always check assumptions before applying results. And the interpretation is done in context of numbers so that the public it can make sense with public health knowledge, as well as adjust for multiple confounders when needed. Now, the applications, we can identify risk factors like smoke. In case of smoking, we can identify this. In case of lung cancer, we can identify smoking as a risk factor, predict outcomes, control the confounders, and support policy making. For example, seatbelt laws for accidents and vaccination programs for infectious disease. Then there are certain limitations. One is assumption violation. If we are not following the assumptions, we are going to have a bias in a study, repeated many times. Number 2 is confounding variables. If we are not adjusting the confounders, we are going to have false impression of association. For example, missing socioeconomic status when studying smoking and lung cancers. Multicollinearity. So when the predictors are highly correlated with each other, it is very difficult to isolate the individual effects of the variates. So this can lead to unstable coefficients and inflated standard errors. Example would be if you are using BMI and based circumference for prediction of diabetes, we would not know the individual effect of both of these. Then overfitting, which is including too many predictors for small sample sizes, causes the model to memorize the data rather than find a general pattern. The model will perform well on sample data, but poorly on the new population. Mnemonic will be too much fitting, too little predicting. Cannot prove causality. Regression shows association, no causation. Even with statistical adjustment, causal inferences requires randomization trials or strong epidemiological evidence. So sensitive to outliers. Outliers can distort regression coefficients heavily, especially in linear regression. So a few example values, extreme values can lead to wrong conclusions. Example will be a few extremely high income can distort average income predictions. And this is true for multiple linear and linear regressions, that it is limited for non-linear relationships. So standard linear regression assumes straight line relationships. If the true relationship is non-linear, results will not accurately reflect the reality unless the model is modified. For example, the polynomial regression is used. Public health example is risk of stroke versus age may accelerate exponentially, not linearly. Now, the recent advances, review of the guidance papers on regression modeling in statistical series of medical journals. This is the title of the journal, title of the article. Here is the abstract. Although regression model plays a central role in the analysis of medical research products, there still exist many misconceptions on various aspects of modeling, leading to faulty analysis. So within each article, two independent rates analyzed content by investigating 44 predefined aspects on regression modeling. We assessed to what extent the aspects were explained and if examples, software advices and recommendations for or against specimen methods were given. Most series out of 2044, 21 by 23 included at least one article on multivariate regression. Logistic regression was the most frequently described regression type, followed by linear regression, Cox regression, survival models, and Poisson regression. Most general aspects of regression modeling, like model assumptions, reporting, and interpretation of regression results, were covered. We did not find many misconceptions or misleading recommendations, but we identified relevant gaps, in particular with respect to addressing nonlinear effects of continuous predictors, model specification, and variable selection. Specific recommendations on software were rarely given. Statistical guidance should be developed for nonlinear effects, model specification, and variable selection for better support of medical researchers. Moving on to the MCQs. Number one is a researcher is analyzing the relationship between the number of hours the students study and their exam scores. After collecting data from 50 students, the researcher uses a statistical technique to predict exam scores based on the number of hours studied, which of the following best defines the statistical technique the researcher is using. A, the method to summarize the central tendency and variability of data. B, the method to examine the relationship between two or more variables and predict one variable based on the other. C, a method to categorize data into distinct groups without considering numerical relationships, or a method to assess the cause and effect relationship between variables without considering predictions. Beta. Yes, beta is the correct answer. A method to examine the relationship between two or more variables, predicting one variable based on the other is the correct answer. 2 is a researcher uses the least squares method to model the relationship between hours worked per week and monthly income, minimizing the sum of squared differences between observed and predicted values. What does the least square method do in this study? A, calculate the average income based on hours worked. B, determines the exact income for each participant. C, finds the best fitting line by minimizing the sum of squared differences. D, classifies participants into income group based on hours worked. E, identifies the cause of income variation based on hours worked. Yes, Charlie is the correct answer. A researcher is using linear regression to predict a student's exam score based on the number of hours studied before performing the analysis. The researcher checks for certain conditions that must be fulfilled. Which of the following is a key assumption in linear regression? A, the dependent variable must be categorical. B, there must be a nonlinear relationship between variables. C, the residuals should be normally distributed with constant variance. D, there should be a perfect correlation between the independent variables. E, the sample size must be greater than 1,000 participants. Anyone? So Charlie is the correct answer, which shows that the residuals should be normally distributed. The normality with constant variance as well as the homodicity. So these 2 points are covered here in this Charlie point. Number 4 is a researcher uses logistic regression to model the probability of the lung disease based on smoking status in 500 adults. What is the purpose of logistic regression in this study? Alpha, to predict the exact number of lung disease cases. Beta, to model the probability of the lung disease based on smoking status. Charlie, to estimate the mean lung disease score. Delta, to calculate the average number of cigarettes smoked. And eta, to determine the cause of lung disease in smokers.
Beta.
Beta is the correct answer.
Yeah.
Beta.
Yes. 5, a researcher uses multiple linear regression to model healthcare spending based on age, income, and education level. What is the purpose of multiple linear regression in this study? Alpha is to model the relationship between one factor and healthcare spending. Beta is to predict healthcare spending based on multiple factors. Charlie, to classify participants based on healthcare spending. Delta, to estimate average healthcare spending for income groups. And eta, to determine the cause of healthcare spending variations.
B.
Yes, beta is the correct answer. 6, a researcher is studying the survival time of cancer patients based on factors like age, treatment type, and tumor stage. So the researcher aims to analyze the time to an event using the data. Which statistical model would be most appropriate for analyzing survival data in the study? A, linear regression. B, logistic regression. C, Cox. D, ANOVA. E, chi-square.
A. Charlie.
Yes, Charlie is the correct answer.
Logistic.
No, logistic would be for the binary outcomes, like the disease is present or not. This is the survival data. We have to see and the time event is given. So these are the terminologies that we have to look for Cox regression. 7, a researcher uses linear regression to predict sales based on advertising expenditure. After fitting the model, the researcher notices some data points that are far from the regression line and is concerned about potential confounders. So what should be done by the researcher in interpreting the regression results? A, outliers can heavily influence the model and should be checked. B, a high correlation between variables always means one causes the other. C, confounders may not affect the relationship between the variables. D, the regression model can work even if the data is not linear. E, a strong correlation automatically implies causation, so confounders don't need to be addressed.
Alpha. A.
Yes, alpha is the answer. 8, a researcher studies the relationship between exercise hours and body weight using correlation to assess the relation and regression to predict body weight. What is the key difference between correlation and regression? A, correlation measures the relationship strength while regression predicts the dependent variables. B, correlation predicts body weight while regression measures the relationship. C, regression measures the relationship while correlation shows strengths. D, correlation is for categorical variables and regression is for continuous. And E, regression measures variability while correlation gives exact values.
Alpha.
Yes, alpha is the correct answer.
Alpha.
9, a researcher uses linear regression to predict patients' recovery time based on age, medication, and exercise, but finds the model struggles with extreme values and non-linear relationships. So what is the key limitation? A, linear regression assumes a linear relationship and may struggle with non-linearity. B, the model handles extreme values well. C, multicollinearity is not a concern. D, the model works fine even if residuals are not normal. And regression predicts outcomes outside the observed range accurately. Anyone?
Alpha.
Yes, alpha is the correct answer. 10, a public health researcher uses multiple regression to study the impact of air pollution on respiratory diseases, controlling for factors like age, smoking, and socioeconomic status. What is the main application of regression in this study? A, to determine the cause of respiratory disease. B, to predict respiratory disease incidence based on pollution and other factors. C, to classify individuals' disease risk. D, to calculate average pollution levels. And E, to test for pollution control effectiveness.
Beta.
Yeah.
B.
Yes, beta is the correct answer, which is to predict the respiratory disease incidence based on pollution and other factors. Here is the key to the MCQs. This is the link to the YouTube channel where the presentation will be uploaded shortly, and thank you for your attention.
Thank you very much, Dr. MOMENA. Very nice presentation and very good MCQs that you have presented. As we all know that binary logistic regression is one of the most used statistical tests in healthcare studies. The different examples that you have shown, these examples are very much needed for every student to get a deep understanding. And I was observing during the MCQ session that there are very few people who are able to correctly give the correct answers. So I must say that everyone should master this technique this statistical regression analysis, especially the logistic regression analysis, is very much concerned with these diseases, as we are dealing with usually two outcomes: either the disease is present either, or disease is absent. So in both cases, logistic regression helps us to find out the independent variables and the factors that are independently associated with it. Dr. Momina, would you please go to your slide number 35? I have a question for you.
Okay, ma'am. Ma'am.
In conclusion, in the point 2, you have shown that always check assumptions before interpreting results. What do
Yes.
you mean by this?
Ma'am, because we have certain assumptions for different types of regressions. We have seen that if we are not going to check these assumptions, like if the data is not linear, or if the data is not normally distributed, or if the data has no homogeneity in it, we are going to get certain false results for that. As we have seen in the
Okay.
limitation part, we have different examples here also.
Would you please go to the limitations too? Yes.
Yes. So we have these assumption violations and confounding variables. And so we have seen that, if, for example, go for confounding variables. So it is important. Example is missing socioeconomic status when studying smoking and lung cancer. For if we are not properly looking for the confounders, so confounders are those variables that are basically affecting the effect as well as the outcome. So if we are overlooking the confounders here, we are going to get a false result. So this is one of the limitation. Then we have multicollinearity as one. Like we are not supposed to have a multicollinear variable. These are
Okay. How to analyze the multicollinearity?
How to analyze the multicollinearity? Ma'am, I don't know that. Sorry.
Relational analysis, and you have to identify all the variables who are significant in correlation analysis. Then you would put those variables aside and run the regression analysis for rest of the variables.
Okay.
To make sure that the assumptions are fulfilled, the sample size should be large. And number second, the uh, before running the regression analysis, you should run the correlation analysis to rule out the collinearity. Number third important point is, as you have said, that the data should be normally distributed. And number 4 point, that is must for the binary logistic regression especially, and also true for the other regression analysis, is about the if variables that are dependent independent, they should be clearly identified. The dependent variables, if it is logistic, it should be in the form of binary variables. They must have yes or no, or the definite values must be assigned to them. While the independent variables can be qualitative or quantitative, it can be categorical or it can be numerical. So these are the few assumptions that should be fulfilled. Thank you very much. A very good discussion on today's very important topic. Regression analysis is one of the most important skills that I want all my students to learn. Thank you very much, everyone.
Thank you, ma'am.
Thank you, ma'am.